Whereas if the same phenomena, like spontaneous process, if we do these things by different manners, like if we divide that mass into small pieces, and if we remove each piece step by step, then we will get a different different state, different point at each and every time as we remove the pieces of mass. And at last, after doing so many processes, we will reach to the P2 and V2 uh, state. So it start from P1 V1, then it may be P1 V1 dash, then P1 V1 double dash, like that, and at final we will reach to the P2 V2. So by doing so, we will get each point like P1 V1, then P1 V1 dash, like that. So we will have a series of series of property, and by joining them we can define that which process is this, because there are various kinds of processes like isothermal, adiabatic, polytropic, different kinds of processes, and by that we can define that this is a quasi-static process. So yeah, a process which takes place in infinitely slow manner, in which each and every state is in equilibrium. That experiment shows that each and every state is in equilibrium, so it is takes place in infinitely slow manner, which is what we call as a quasi-static process. And if quasi-static process is a frictionless, then it is always a reversible process. But we have to remember that one thing is that all reversible processes are quasi-static processes, but all quasi-static process need not be reversible. Only frictionless quasi-static process can be the reversible process. That you should keep in your mind. Then thermodynamic cycle. The next topic is thermodynamic cycle. A system is said to be undergoing thermodynamic cycle if initial and final states are same. So we can say consider a process in a circle which starts from state 1, then 2, 3, 4, and it will be end up with state 1 only. So whatever process, it must be enclosed, and change in properties for cycle is 0 in this case because it end up with the starting point. So we can say that the change in property is 0 in case of the cycle. And we can know that minimum 2 processes are required to complete a cycle. You can see the figure. The 2 processes are required to complete a cycle, to enclosed up process and make a cycle. And in nature, a linear cycle is available and in working condition, which has 3 processes. Minimum 3 processes are there in working cycle, which is a linear cycle available in case of practical in thermodynamics. Then next topic is thermodynamic equilibrium. A system is said to be thermodynamic equilibrium if there is no any unbalanced equation. Unbalanced equation means we can say that a driving force within the system. If there is no any unbalanced force within the system, then we can say that the system is in the thermodynamic equilibrium. 3 types of equilibrium are necessary for this. Now the system can be only thermodynamic equilibrium if these 3 equilibriums are satisfied. And first is thermal equilibrium, means no heat transfer. Temperature must be constant. Mechanical equilibrium means equality of work. Chemical equilibrium means chemical equation and no mass transfer. Chemical equilibrium, and no mass transfer. In this case, if these 3 equilibriums are satisfied, then we can say that the system is in thermodynamic equilibrium. Yeah, and we know that the mass transfer, heat transfers particularly because of the temperature difference, equality of work by causes of force on the system, and mass transfer is basically due to the concentration difference. So these three things, if satisfied, then we can say that the system is in thermodynamic equilibrium. Now the most important topic for any examination, particularly for competitive examination, one question is always from this: is ideal gas. A gas obeys ideal gas equation at all pressure, temperature and volume, known as ideal gas. In case of ideal gas, there is no any intermolecular force. If intermolecular force present, then it shouldn't be ideal gas. It is called as a real gas then. And by experiment or phenomena, we know that at low pressure and at a very high temperature, any gas can behave like an ideal gas. Yeah. So these questions also many times found in competitive examinations, that which conditions can make any gas behaves like ideal gas. So low pressure and at a very high temperature, any gas can behaves like ideal gas. And ideal gas are basically two types. It is a perfect gas and semi-perfect gas. Cp and Cv of gas are constant, then it is called as a perfect gas. Whereas Cp and Cv are function of temperature, then it is called as a semi-perfect gas. Now Cp and Cv, we will talk about these later, but in ideal gas equation is Pv is equal to mRT. P means absolute pressure, which must be in kilopascal for this equation. V means volume in meter cube. M mass in kg. R characteristic gas constant, kilojoule per kg into Kelvin. And temperature, T absolute temperature, it must be in Kelvin for this particular equation. And many times you will find out the questions like what is the ideal gas equation in competitive examinations, in state level examinations. So remember this formula: Pv is equal to mRT. And here we can say that m is equal to n into m, means number of moles. N is equal to mass divided by molecular weight. So n is equal to n into capital M. So we can write the equation further, that Pv is equal to nmRT, where mr is a constant, and this constant we can define by r bar, which is known as a universal gas constant. Universal gas constant is it has a particular value, is 8.314 kilojoule per kilomole into Kelvin, and so we can modify this equation as Pv is equal to n r bar T. And yeah, and the value of characteristic gas constant kilojoule per kg into Kelvin is 0.287 kilojoule per kg into Kelvin. So you also remember that value, and this is a really important topic, so remember this formula. Okay, then next, yeah, Avogadro hypothesis. Avogadro hypothesis is a statement provided by Avogadro, and it says that at particular pressure, temperature and volume, number of moles are same for all the gases. Number of moles are same for all the gases at particular pressure, temperature and volume, and it is given by the Avogadro. It is known as Avogadro hypothesis.